I'm kind of recording now. So can you go
I think
back?
your voice is recording.
Oh yeah. Can you? Yeah, great. Okay. It's fine.
Okay.
Yep.
Hello everyone. My name's Richard. I've been working in the games industry for the last 12 years. 4 of those were at a large company in England. So that's a 600-person company. Since then I moved to Norway, thanks to the EU. So I got in there just in time. And I've been working at small independent studios in Norway. There's quite a few now. When I joined there was only about 10, but now there's like 150 indie studios in Norway, and they predominantly use Unity, which is a tool I'm going to show you now. A lot of you might be familiar with it already. So I hear that you've all installed Unity, the latest version. Excellent, good. I managed to find an up-to-date GameKit. There are quite a few, but it is quite large. And like a lot of packages on Unity, they do require you to install the dependencies. So I did go through all of them and fixed quite a few of the bugs. So I don't suggest that you download this right now, but you probably should do it afterwards. And install these dependencies here, but I think we can send them an email using Blackboard. Okay, so this project, if I can just find.
I can minimize this.
Now, let me just find the 3D GameKit. Okay, so if you've got 2018 0.1 or 0.2, then this will work fine. This is a full game kit. It's an entire game world by the looks of it, and you can just go in and you can see how it works. So we're going to go through and we're going to look at the different aspects of Unity, but this is probably the best example out there. So Unity, if you're not familiar with it, is a unified development environment. What do I mean by that? Well, when I was working at the large studio, which had 600 people, we were split up into different teams. There was a tools team, game engine development team, which I was part of, a game logic team that helped game designers, and a game design team. And there were 4 sub-studios who were working on different products that were all utilizing the same game engine technology and build tools. Unity basically does the job of those 300 people, so you don't have to. So this means that you can get a game out with just you, an artist, and another friend, potentially. So it's really good for you in groups, because you can do what I wasn't able to do when I was younger, basically. Unity also provides a platform-agnostic middleware, so that allows you to deploy to many different platforms. So, like, PlayStation, Xbox, PC, mobile, web. Those are quite hard to maintain yourselves, so Unity does that for you too. Let's just take a look at the game. So this is the game world here. If you're not familiar how to use Unity, you can use the right mouse button to click and hold and drag, and then WASD to move around. That's a bit slow, so if you hold shift, you can zoom around like this. If you double click, you can also press F, which I believe allows you to focus. Yep. So let's check it out. So this is a nice little UI overlay. Unity has its own UI system as well, which is sat over the game world. What they've done is they've created these little filters here, so you can see the different parts. Now Unity uses a scene graph hierarchy. So you have the main scene file here, which contains everything you see in the level, and then under that you have game objects, and these game objects can be parented underneath each other in a hierarchy. So this is what these little filters are. You can see that this one is a collapsed hierarchy, whereas this one is expanded. One of the things to bear in mind with this example is this is a VR enabled laptop, so I play VR games at home, but for some reason this example takes a long time to load, so it is kind of heavy. It's one of these chompers. I was trying to find them earlier. So I believe that these are the bad guys, whatever they are, called chompers. And this is your game character here. It's got a 3D character controller. You can get this as standard from the asset store. The asset store does not work at the moment. Just give me a moment. So the asset store is great in that it's a huge ecosystem of assets that people create and sell. You can download a lot of them for free. A lot of these are character controllers, so it enables like programmers like us to basically utilize a lot of 3D art, rigs, assets that we wouldn't be able to create ourselves necessarily. So let's find the character. Nope. UI lighting gameplay. Where have they put it? Ellen. Okay, so this person is evidently called Ellen. And let's open the scene. Head target. So here you have a lot of gizmos in UI that indicate the different aspects. This is a light, as obviously you can see, and you've got light down there. Let's find. Here's the skin mesh. The shader information you can find here. I'm just trying to find skeleton. Good. Root. Hips. Animator. Okay, cool. So this is the main game object is on the root. You have C# scripts here. Who's used C# before? Okay, a few of you. Well, C# is very much like C++. You should be able to transition okay. One of the things it does is it manages memory for you. And when an object doesn't have any references, it gets cleaned up by the garbage collector. This is something that you might be familiar with if you're using modern C++. But yeah, generally it kind of simplifies things. So let's look at the player controller. So the base class of all scripts in Unity is something called a MonoBehaviour. MonoBehaviours can be attached to game objects, which you can see visible in the hierarchy here. And each one of these components has a purpose. This is quite good for scaling up your game, so you don't have just one big class that does everything. One of the things that I'm actually a little bit critical of with Unity is their text can sometimes be a little bit erratic in the way that it's laid out, so you can just have a big blob of text which can make it a bit hard to read, but otherwise it's very good, it's very functional. So this script basically defines how it runs, but how it's moved is defined by the animator. So the Unity animator is a hierarchical state machine. It allows you to have exclusive states of what the character's doing. If I can just zoom in here, you can see that the character is currently idling, and it's going through different idles. And there are certain conditions that allow the state to move between different exclusive states. So if I start running, it's going to go into the local motion state machine. And here it blends between the different animations. So I'm running forwards, now idling, and then you can go back up again. So the animator states have an animation. And what you can also do is you can also add scripts to the animator. So while MonoBehaviours are your components that you attach to your game object, animator states also have behaviors, but these are animator states. So let's say if I want to do a state callback, let's put this on idle. Now, I guess it won't let me do it at runtime. So yes, Unity will create a class view, and it will comment out all the different callbacks that you can implement. These override virtual methods on the state machine base class. So you can override all of these methods and basically write scripts directly into your animator state machine. I recommend that you do that whenever you've got a character or something that's defined by animation. So let's say I wanted to create something. So if you want to reference something in the script, here you have integer fields that you can specify. You can also specify game objects or prefabs. In this case, I want to reference a game object, but I can't see it if it's private. I can see it if it's public. The only downside about having public fields exposed is it can encourage you to make your code like spaghetti. So that's generally a rule of object-oriented programming, is you want to keep data controlled by its own class. So what you can do to make this appear is you need to tell Unity to save that to the scene file. So a term that you should know is serialize. That basically means to save something to another format, like text or binary. So yes, now we've got an empty game object, so we want to spawn something. Let's download an asset. Let's download some particles. Where are you? Huh. Oh, maybe that asset's gone. I was looking for a particles pack. Let's find some. Price free. Yeah, let's grab this. So I haven't actually used this before, but I'm just going to assume that it's going to be fine. What? It means he does not like me today. Is it plugged in?
You use the Unity store from within Unity, or you use it from the web?
Well, it doesn't seem to. I need to sign into the web to download the asset. Alright, now it's working. Okay, so I've mentioned scene files, which is this thing here, but these blue highlighted game objects are what we call prefabs. Prefabs are like, it's basically a prefabrication of game objects that you can spawn dynamically into a scene. And that's kind of like a scene file in that you might have like lights, models, scripts. When you have prefabs in your scene, the information about that prefab isn't actually saved in the scene file, it's saved in the prefab file. But if there is any particular differences in the prefab, like say I disabled this box collider or disabled this script, then that change would be saved in the scene file. Okay, let's find the particles. The prefabs. Example cloud, example dust. Cool. So let's find Ellen again. And go back to idle, find our script, and let's drag the dust in. So now what we can do is we take the game object and we can instantiate it. So to instantiate something is to basically make an instance of it. So what we want to do is we want to spawn this instance of a particle at the feet of the character when they go into this idle state. So this instantiate method has a few overloads. One of them is the transform. A transform is the position, the scale, and the rotation. The rotation is represented as a quaternion, but you can change that to a vector 3, which is like a Euler angle. So that's like your pitch, roll, yaw. You might find it easier to work in Euler angles and then convert back to a quaternion. But yes, you probably won't get gimbal lock like the Apollo 13 spacecraft was worried about. That's when you align your gimbals and fly upright. So we need to get this transform. How do we get that? We can get this gives us the animator, and then from that we can get the game object, and then we can get the transform. Let's put that straight in. Do we want to instantiate in world space? No. We just want that. It's going to return the game object, so let's just keep the game object. Let's store it in another field. This is just the game object, but what you can do is you can get the components, which is the base class in the hierarchy. So if you're familiar with inheritance, that's you are, then the class hierarchy is the MonoBehaviour, and then I think it's behaviour down to components. Component just has some basic functions like add, remove, reorder. So the interesting one you want is MonoBehaviour. So this allows you to get anything from a component upwards. So in this case, let's try and find the particle system. Then, assuming the particle system isn't null, assuming it's there, what we can do is we can set it to play and all children to play. We might want to check if the particle system is playing or not. Is playing. Let's say if it's not playing, then we will play it. Okay, let's give this a go. Oh, I'm just going to add something quickly here. So what I'm going to say is if my particle instance does not equal null, then I'm going to return out of this function because I don't want to spawn lots of particles. So hands up who's used Unity while we wait for Unity to load. 3 people. Have you made any games yet, or have you just been playing around? Sorry, I can't. Oh right, okay, so you did it at People's High School. I think that's what it means. Aha! So here we can see. I don't think it was this smoky beforehand, so I think that's me spawning it. But there's no instance, so perhaps not. Why are you not running? So one of the things that you can do in Unity to test if something's actually working in code is you can attach the debugger to Unity. Let's just do it now. I've created a breakpoint here. Ah, and then it's... has that paused? No. I think I know why. Is this actually... this might not be the animator that we want. Let's start it again. We need a break. Are we halfway through? Okay.
So, do you want to ask for a break or do you want to continue?
No, 10 minutes break.
10-minute break. Okay.
Okay, can you unlock so I stop the stream? I mean, I don't stop the stream, I just stop the microphone. Yeah, so if you go to the stream and click on the next icon.
10 minutes.
10 minutes. Is that 10 minutes?
Is that 10 minutes? Yep. Is everyone back?
Okay. Is everybody back from their 10-minute break?
Unmute the microphone.
I've unmuted it. I've unmuted it. Right. Hello, everyone. We're going to start up again. Just a quick question. I understand that some of you have done programming, but some of you might not have done programming. So who's following what I'm doing here with debugging? Yes. Good. Okay, cool. So you guys probably know how to debug, and then some of you probably don't. So the ones that don't know how to debug, these guys will help you learn how the tools work. So I don't want to just set the expectation that you have to understand everything and you can go away and you could make this like highly involved game here, because you're not going to be able to make a game like that. Like not even a third year is going to make a game like that at the end, because there's just so much art in there.
Yeah.
So we just want to set these expectations.
Just a question in terms of, okay, when you develop a game, right, so in practice, so how much time out of the 100%, right, how much time do you spend on art, how much time do you spend on development, and how much time do you spend on, you know, design of the story of the game?
It's a good question.
Just to give a feel, so everyone has a kind of somewhat expectation.
Okay, so after I left some of the indie studios and started my own, we hired two artists, a 2D artist and a 3D artist, and to make like 6 different animals that you can interact with took 1 year. And in Norway that's kind of quite expensive as well. That's like, I don't need a deposit for a house, I'm going to make a video game. So yes,
Okay. So it takes time, you suggest.
it does take time, yes. So the great thing about the asset store is you can just get these assets for free, though. You don't have to pay someone to make them for you. So I highly recommend that what you guys do now or when you go home is just to open up Unity, find some nice assets and put them in the scene and start from there. It's going, don't worry.
Good.
Cool. So, I mean, the great thing about Unity is if you get stuck and something isn't working, then you can attach it, and then you can click here and create a debugging.
So who knows what debugger is?
Debugger? Anyone?
Debugger. Okay, so Visual Studio is your...
Who knows what Visual Studio is?
Yes! Good.
Good.
Good. So we're
Awesome.
already at an advanced level. So yes, Visual Studio, this is your development environment. Here you have your script file and you can put in a breakpoint, and then you can step through the game live and see what each line of code is doing. So here I'm instantiating an object, I can step over, and then this object is created, and then you can find out all this information.
So you haven't had object programming yet, right?
Object-oriented programming? Nope.
No.
No, we're not. Cool. Sorry? We are planning it right now. Oh, you're having it right now, right? So, okay, you talk about hierarchies, encapsulation.
Okay.
Oh, okay. So let's take a step back. So how many of you get an understanding what Unity is for and about so far? Who has a good understanding?
Make games in it.
Who has somewhat of an understanding? Okay.
Somewhat's
okay.
good.
Who says no clue, whatever? Cool, that's honest. I like honesty. So
Cool.
okay, we have a chance. In order to actually develop a game, right? So what are the minimum things that we need to know or do in order to get something off the ground Unity? I mean, if you have never dealt with so for the person there, I think Unity is for game development. That's the only thing you can read for now, up now, right? So and everyone has some sort of programming background, a little bit at least, right? 1 semester of programming, cool. In which language? PHP, okay.
Oh,
for you guys.
I mean, yes, that's fine.
C++ for you guys, okay. Any other strange dialect or language that you have come up?
Any Java game developers? Java developers?
Yeah.
Some Java, yeah.
Good, some Java, good. Yeah. Okay, so that's a bit. So diversity. So we're kind of on C# here, right? Aren't we?
Or on C#, yeah. So.
Okay, that's the lesson learned.
But then that's quite familiar. For C++ and Java developers should be quite comfortable.
Okay, yeah. It's
So-
fairly similar.
So C# is very similar to C++ and C and to Java. It's not similar to PHP at all.
That's tricky.
No,
Yeah.
and that's a good thing.
Well, it can be. We need to still figure out a way there. But if you want to develop a game using this, so what are the simplest possible things that we need to think about? Assets, you mentioned, so that's good.
Yes. So let me just
So you're not spending a
Stop
year developing
this.
assets.
Yep, you get assets from the asset store.
What else?
Unity has decided to
To stop talking to us.
stop talking.
So
It's probably because it's still debugging. Stop. And then I'll just stop this. So yes, this scene is very complex, but the best thing to do is probably just to start with the simple scene and to drag these assets in, which are free.
Right.
So, like, let's find this mushroom, for instance.
So if there's a base scenario, a Hello World style scenario that you could imagine in Unity, what would that be?
The worst scenario,
No, Hello World
the
scenario.
Hello World scenario.
A Hello Unity scenario.
Let's just stop this because this scene is full of assets and it's quite slow.
It's very rich, yes.
Okay, back to basics. So it can look like this once you put everything in, but chances are your first scene is going to, I've just gone to the project window here, so this is all the files in the game. So you have the script files and the scene files. So if I right click, I can create a scene, and it's going to be somewhere. It's going to be here. And then I can name it class example. If we open up, very simple, has nothing.
It's an,
A grey void of lifeless form.
so it has the void and it has the
A directional light, which has nothing to
and
light.
skybox.
And a skybox.
Yeah.
What is the skybox?
It's this blue thing.
Ah, the blue. So we talked about terminology so that we know what we talk about. What's the skybox? That blue thing.
It's the big
So much about that.
That's what it looks like. Big
Yeah,
thing.
that's
so
right.
if you have your character here, let's say this is you and you're looking via this camera object. You can see it from this little cinematography icon. So imagine that this guy has a camcorder on his head. And you can see out into this 3D world. The skybox, big blue thing, it's like a cube. In geometry. So that's a cube. You're just going to have to believe me. It's an art.
Richard is not an artist. He
Not an
is a
artist.
programmer.
Yeah, that's why I hire artists. Okay, so trapped within this cube, you are surrounded, and it stalks you. So whenever you move forwards, the skybox moves with you, so you can't see that it's actually a cube. So it looks like you're just infinitely going off into the distance, and the sky is just getting further and further away, and that's because it's moving with you.
Yep.
And that's how skybox works.
Oh, that sounds good. And then you drag something in there.
Yep.
Yes. So I talked about prefabs before. So let's find some prefabs. Let's go to the 3D GameKit. Prefabs. Environment. Clouds. That's a good
Those
thing.
are good.
Yep. Let's drag them in. Ah. It's like your god in a way. So in the first day you created the sky. Then create some water. That's not water. That's really not water. That is a badly named asset. Bad asset. So yes, I have a Scum texture. Interesting. Let's change the color. Let's change this color. What's that going to do? Nothing. So this texture can be swapped out. Let's just try and pick something.
Something different.
Something different. Muddy ground. Muddy ground, go. I choose you. Yep. Okay. So, right, now we have some ground at least. And if I select this, is it selected? Never mind. Okay. It's just very big. So what I want to do is I want to put that little cute monster that we saw before. Can anyone remember what his name was? It wasn't Grumpy. It was something jumpy. It's going to be some actiony word, isn't it? Chompy, was it? Chompy, yes. Chomper.
So you have this little search field.
Yep.
Because you have a hierarchy of different things on the left. Yeah.
Yeah. I've spent like 6 years doing this, so I'm just like yes, yeah, and then I do this. And I'm not thinking.
And then you can quickly search for the assets by name.
Yes. You can also filter it by type. I think here.
Yeah.
So animation clip, font, mesh, prefab, scene. So yeah. So let's look.
Yeah, when you start, the left-hand side is quite simple. Like you pretty much don't have much. But if you import a project like this one, or if you have a lot of assets, it becomes kind of unmanageable. And then you just quickly use the search box to find things.
Yep. You also have these tooltips here. So these do different things. You've got rotate, and this will change the gizmo. So it'll give you a broader idea about how it works. You've got scaling. This is a 2D tool. This is a new tool that's come out today. I haven't actually used the new version of Unity, so I'm actually still learning about it myself. So this one does move, rotate, or scale selected objects. So I think that must be sort of it combines or you deselect things. So let's just go through these basically. So this is a move. You'll see that you have this gizmo which represents the axis. So Y, X, and Z, and you can move them around. Let's just get my camera to actually point at Chompy here. Looking the wrong way, I think. Yep. So let's spin it round. I'm going to select the rotate tool, and then I'm going to get my spherical rotation gizmo, and then I'm going to pick the axis. And then I'm going.
And as he rotates the camera, you can see in the preview window, the view that you see is actually being rotated. Where's
Chompy? He's up in the air. Oh yes. Is that him? Is it a bird? Is it a plane? Okay. No, it's Chompy. Yep. So let's rescue Chompy. Move him down.
Yeah.
And he's very small, so perhaps we can make him a little bit more intimidating by using the scale tool. That does shift. Nope, that's not what it does. Sorry, I can't hear you again.
He says if you click in the center, you can.
Then I can scale all of them once.
Yeah, yeah.
Cool.
Yeah.
Box the ratio.
Yeah.
Yeah.
It looks scary.
Looks quite good. Just pull him down and push him towards the camera. Okay. So here's Chompy. But Chompy, he is what we call a navigation agent. So he's supposed to run around on this navigation mesh. And we don't have one of those yet, so we need to create it. So what we can do is...
So is it like waypoints that we create, or
navigation mesh.
Let me run to the board. Guys, if you have questions while Richard is running through all those points, right, just, bring them up, right? So that should be a bit of an interactive exercise here. I think so far you can follow, right, with the placement of the entity in the center and so on. And we'll see that we figure out some, basic exercise that you guys can do it at home, and then, bring your questions back that you may actually have when doing it. But it's more like giving you a bit or a brief overview, but also clarifying terminology, right? Sky was with one, and now the navigation mesh, whatever that may be. Richard.
Okay, so I'm going to draw again.
Word of warning.
This is you with your camera, and then you're standing on this mesh. And this mesh might be really kind of jaggedy. You might have some rocks over here, flower. If you wanted to make that character run over that mesh, that's not a very good mesh to run over, because it's, like, you're probably not going to want to run up here and stand on the leaf. It's quite an odd-shaped object, so you probably don't need all the little precise crevices. So what navigation mesh is, it's a simplified mesh that defines the walkable area of the agent. So what you might do is you might have a mesh that runs up here. Maybe it rounds it out to make it a simple slope. And you can't get here because there's a drop. You can't get up here because the inequality are. So Unity calculates this for you, and then it will give you a little blue highlighted area where you can see this is where the characters can run.
If you have played games sometimes, right, you have this in non-open world games, right, where you're actually running the character and you're running against the wall, the character is still animated and running, but actually won't move any further, right? So that's basically where it hits the boundaries of this navigation mesh, right? So
Yeah.
Who knows what's a mesh? What's mesh?
Mesh. Well, okay.
Richard will explain.
Okay, so mesh. Think of it like a cloth or a chain link,
very good one.
or a chain link fence or something. So it's divided up in all these quads and triangles, but when you look at it, it's just a surface, a shape. And the cloth example, I guess I would describe it as like if you had an object like this and you threw the cloth over, you would have this connected surface that loops over everything. And that's really what a mesh is. It's just this point.
And in 3 dimensions, right?
Three dimensions, yeah.
Makes sense? Yeah, mesh. So having 3-dimensional points being connected. So it's not just points that you jump between, but actually continuous, surface, right? Like a, like exactly like the device you showed there, or a table or something like this. So it makes sense, and your character actually walks on this surface, right? And you don't need to model each individual points, because if it's the surface, all the points in between are connected automatically, right? Like the cloth example, right? So you only care about the core points there that you highlighted in your model there.
Yeah, so
and the rest is filled up automatically for you.
So if you have a cloth, and you zoom in, you end up with the thread and the hole. It's like there's an empty space, right? So a mesh actually fills it up. It's kind of it's the surface connecting the points. So that forms the whole cloth without having any holes. So the cloth is a good example, but without a microscope, right? Because otherwise it's not exactly a mesh, because it actually is it has full of holes. And the mesh, the one which we talk about, is continuous. It's like it covers the space into a surface.
Yeah. Nice. Okay. There are a number of 3D objects which you can create, and it gives you like a default mesh that you can play with. So you've got cube. You've got. I mean, you know what shapes are. So I'm not going to explain this to you. But this is actually going to be relevant having these. So these are all very high up again. Let's make them big. Let's zoom. let's drag them down because I want to show the nav mesh thing. So let's just say this is a untextured city, and these are skyscrapers, or they will be skyscrapers, but maybe you just want to white box it. You just want to put in white boxes that represent this will be a skyscraper later. Yeah. So this giant chompy monster, he doesn't want to run up the skyscrapers. So what we can do is let's add a navigation mesh, nav mesh surface. We'll assume that's what we want. Nav mesh circle, cool. And here Unity has provided you the different fields that you can set it up correctly. So what we want is we want Chomper to be able to walk on it, and we want him to say he can walk on all these surfaces, and default areas walk all. So this tag, this layer is water. So these are the different layers. It's a way to categorize basically what your meshes are. So in this it said water. Let's call it terrain. And let's rename this water because it's not actually water, but let's call it grounds. And let's try and bake this nav mesh and see if it turns blue. This is calculating the walkable areas. Great. It did. Good. So here you can see our chompy monster. He can walk anywhere on the ground that's flat, and he can potentially get on top of the skyscrapers. Yeah. So let's press play and see if this chomper walks around, because he should be able to. The good thing about prefabs is they should be set up so you can just drop them in and they'll just work. Oh no! Yes, it kind of works. To infinity and beyond.
We lost him.
We lost him, yeah. So.
Rest in peace, Chomper.
So yes, there was a problem here because he seems to be using gravity.
Yes.
And he doesn't want to collide with the ground.
Part of the thing is that those tools also model the physical world, right? So because they model the intuitions by which we work, right? And we have gravity, but that's actually not what we want right now, right? So we just want to walk around the flat surface. So all those aspects then need to either switch off and on. So there's a lot of configuration necessary to get that right. So how do we get them?
So the issue is the mesh collider is turned off.
Yeah, we want him to collide with the ground so he cannot go through it, right? That's what happened before.
Yep. So let's see what happens when there's a mesh.
So you switch it on? That was a Boolean flag.
Yep.
Turn it on.
And well, he's not falling.
But he's not walking either.
Let's see. Let's look at his animator and see what he's doing. Cheap fellow. So he's in the idle state, and then it just seems to have stopped. I don't understand why.
Yeah. So the game object can have some animations attached to it, and the window which Richard has on the right is the kind of a state machine which says what are the different states you can be in.
Yeah.
And he is currently in the idle state, kind of doing nothing.
Yep. That's strange and disappointing.
So for your game characters or for your NPCs, you will have kind of similar state machines saying, okay, is the character standing, is the character walking, running, jumping, and so on, and then by interacting with the keyboard or mouse, you can instruct the state machine to change to a different state and animate a different behavior.
But there's a number of other assets you can get. Let's look at the stone wall, see what these are. We got stairs, I think.
And also what Richard was saying about prefabs is they often come with the mesh, with the texture on top of the mesh. What is a texture? Do you know? Yeah, it's kind of like a overlay on top of a mesh, right? They come with the scripts and with the configuration of how it should work. So that's what we were hoping, that the monster will come with the script which allows it to walk around automatically. So the prefabs are quite useful because you can just drop them into your scene and they will come with all this functionality kind of attached.
Yep. Supposedly. So.
And then, yeah, on the right-hand side, which Richard is scrolling now, there is this properties panel.
Yeah, it's the inspect panel.
Inspector, which you set a lot of different parameters and properties of scripts and properties of the object itself and all these children and so on, right? So
yes, yes. So you can add script components. To
yeah.
Yeah, scripts, meshes, nav mesh components. All of these are different things that you can attach to your game objects to compose them.
So there is, as you've noticed, there is kind of a lot of vocabulary that comes with the tool. You have to learn quite a lot of terms, and they are used in tutorials as well, and it's sort of you know, help discussions. Yeah. And so that's one thing, you have to kind of learn the vocabulary. The second thing is you need to learn where things are in the editor, in the Unity editor. Like how can you find where I turn on the gravity on and off, where I do this. Right? Yeah,
this is the default layout, so you can drag these around however you like. And if you mess up, like I do all the time, you can go to Window, Layouts, and then you can revert to factory settings, like with the toy.
Yeah.
And then it puts it back to the way it was. So the default way is to have your hierarchy on the left, which is your scene files and how everything is organized in the world. Then you have the game view, which is when it runs, and then the scene view is what you can actually configure when you set things up. So here I can drag things, here in the game view I can't. And over in the right, the inspector just shows whatever you have selected. You can select multiple objects, but then you get little dashes that says like, that is different between objects. So it doesn't really work if you want to edit two objects at once, but it is useful to kind of select them and move them around as groups.
Yeah, also in the editing view, as you see, he sees the scene from a different camera than the actual camera which sees the scene for the game view.
Yep.
Right? So he can navigate his view the way, you know, anytime, anywhere he wants to manipulate the objects in the scene, which doesn't change the actual camera which overlooks the scene on the left. And he was also before changing the camera which overlooks the scene. The camera which overlooks the scene for the game is the one which will be used when you press play. The one he's navigating in the editor, you know, will just disappear. It's just for editor.
Mm-hmm.
Yeah. And then you have the inspector, right?
Yep. And this is.
And if you double click on any of the scripts or on any of the code, you will have the Visual Studio pop up with the
with the code,
editor.
so you can edit it.
Yeah.
What you might find is with very big scenes it can get a bit slow. So here it's just decided to freeze up on me. Which is wonderful.
All of you are using Windows, or anyone is using Mac or Linux? What do you use?
One Mac guy.
Mac. So on Mac you can install the Visual Studio Community Edition, and it will link with your Unity deployment as well. It's not as nice as the Windows version, but it's good enough.
Yeah. If you might find that you do have some unique development issues when you're working with other people when you're on Mac, but
Yeah.
we've all been there, so these guys
I
can
use
help you.
MonoBehaviour as an IDE, but it sucks. So you really want a Visual Studio Community Edition.
Yep. So I just want to give this guy a mushroom hat. So I'm just going to show you how to do it. So I've just created, I've dropped in a vegetation prefab here, and I'm going to drag that on the hierarchy on top of Chomper's body. I want to find his skeleton though. Let's find his chest. Let's find his upper mouth.
Yeah, so kind of a comment about the hierarchy. Why do we have a hierarchy of objects?
Yep. It might be self-explanatory to some of you, but maybe we should explain it. Yes, the point of having a hierarchy is so stuff comes with you. So for instance, I want to give him a hat now. If you have clothes, they need to be attached to your skeleton. Otherwise, they would just walk off and you'd leave that.
Yeah.
Which you so the hierarchy is very useful, and this is what I meant earlier when I said a scene graph, because it's like it's kind of like a plant where you have different nodes coming off different branches. So it's like a graph structure.
And it starts it's rooted in the scene itself, right?
Yeah.
So it starts at the at your plane there, right, where we saw the skybox initially, right? So everything is modeled in dependency to that one, including Chomper, including those elements there, and so on, right? So if we just move Chomper, the rest is not affected by it, but everything that belongs to Chomper is affected by our move of Chomper from the left to the right, right? Because we need to bring his ugly teeth, his mushroom head eventually, and whatever else it actually has, and move it relative to the scene. So that's why he's talking about scene graphs and hierarchies in particular.
Yeah. I want to turn the
So
lighting
you
off
need
though.
to see it in perspective, especially the ones that of you that big object orientation. This is actually makes your life so much easier. Just imagine you write a program where you need to care about any of those things, right? You're moving something, let's say, you know, this object there, whatever it may be, from the left to the right. You also need to think about its teeth, its tongue, and everything you model on top of it. And the idea is that this kind of tool puts it in a conceptual world that we understand. We see that this is one coherent object, right? Richard is not consisting of his, or Richard is not a composition of his clothes and the top and the bottom and so on, but Richard is Richard in its entirety. So if we move him, we want to ensure that everything goes along with it and don't want to worry about clothes when we actually want to model his interaction with the PC, right? And the same there. So that's why we have those tools where you can just drag and drop stuff from the left and right. So if you think about it, you know, spend some time thinking about it, it's actually quite involved, the mechanics that sit behind it. So the tool actually makes your life a lot easier, even though it looks complicated and the hierarchy looks challenging and so on. But that's actually how we model the real world in 3D, if you want. Right?
Yeah. This is kind of similar to the directory structure in your file system, right?
Yeah.
Let's say you say projects, and then you say ebooks, and then you have C++ subfolder. If you move that subfolder, you move all the C++ books somewhere, right? But if you move ebooks somewhere, you move all the programming languages that you have there. So it's the same here. You will organize your objects in such a way that, for example, an arm, if you move the arm, it moves all the fingers, it moves the textures here and so on, but it doesn't touch the other arm. But if you move the body, it moves both arms and the torso and so on, right? So you kind of try to organize it in kind of logical way that some changes are applicable to that sub-tree of your graph. Yeah, is it a graph or is it a tree really?
Yeah,
you have a tree, right? Why do you call it graph?
Is it acyclic? Can you have links between the different
You
versions?
probably can.
Yeah.
I think it's just it's an old programming concept. Like I think it was in Ogre, for instance. Like Ogre had it a long time ago. So yeah, you have the scene file, and then you have a graph under that, which is all the objects. So there's like one root object, which is the scene root, and then you have the scene graph.
Okay. Yeah.
But you could call it the scene tree, for instance. But there's trees in the game, and then that would be confusing.
Confusing, yeah.
So naming is a challenge in itself.
Yeah.
Okay, so I've now given him his hat.
in a proper place in the scene graph.
Yep, and I'll make his growth a little bit bigger. And this is attached to his stalk, so his neck, if you will. So now if I press play, what should happen is when Chompa's legs rotate, it'll also rotate the object that's parented to his head or his neck. Yep. And now
so yeah, so we know how to kind of roughly create some, you know, game objects, some scene with some obstacles and things, and how to place kind of a character. How would you animate the character? How would you make it controllable by you?
Okay, I think the easiest, if you wanted to control it directly, so like the character, for instance, you wanted to move it around by scripts, then what you would do is, let's say I want to create a capsule, and this capsule will represent a person.
Okay.
Yeah, I'm attaching to Chompa. Cool. So here's our character. Has a capsule collider and has a renderer. Now, if I want to move him, I need to create a script that's going to do that. So let's create a character. Let's call it mover. Create and add. And let's wait for Unity to recognize the script. Sometimes if Unity freezes up and you don't know what it's doing, it could be because there's something in Visual Studio that you have to press, like that reload button, for instance. Okay, so now I have my character move the script. If I double click, it will open up here, and it's given me these two functions because it's assuming that these will be most relevant to me, and they are. So you have a start callback method, so that basically, this function runs when the game is starting up, and then you have an update method, and that's called once per frame, as the comments say. There's a bunch of other ones which you could look into. The startup phase is actually like a two-step phase. There's like awake, and then there's start. So awake runs first, immediately if something is spawned, and then start runs after all the awake methods are called. Yep. So this gives you a chance basically to kind of set everything up on your game object, and then starting is when you want to like make this game object work related to everything else in the scene. So let's say update. What do we want to do with update? I want to move the box if a key's being pressed. So let's say if the input class tells me a key is down, returns true. During the frame, the user starts pressing down the key. And then let's give it a key code. This is an enumeration, so you may not have done enumerations. Who knows what an enum is?
Enum.
An enum. Okay, good. So, as some of you know, an enum is basically a representation of an integer number normally. So, if I just go to the definition of this particular enumeration, you can see that these key codes have a textual form. So key code none is 0, backspace is 8, and then you have joystick buttons should be an arrow key as well. So that allows you to basically say, like, okay, let's have up arrow, which is key 273. So if I just wrote if key 273 is down,
do something.
yeah, you're not gonna
But
know what that is.
You don't remember what 271 was. But if you use enums, they have kind of a human readable labels, and then it's kind of easy to understand what the code is doing.
Yeah, exactly.
Also, if the underlying number changes, you don't need to bother, right? Because you always care about that.
That's true. So let's create an elfis, and let's say down arrow. Let's just do all the arrows. Left.
Yeah.
Left
So
apple. No.
Richard is doing a skeleton for 4 arrow keys behavior when they are being pressed. When he said update is called every frame, what does that mean? Yeah.
Every time the program runs one time, it runs once. The program goes from top to the bottom and then goes from top to bottom again, and one frame is
One pass.
Yes,
One pass through that. Yeah, sort of.
Yeah. It's
There's one. There's one.
Yeah.
So in games we have frames per second. So this function will actually run for each frame. So if, for example, we have 30 frames per second, we will run this code 30 times in that second.
yeah.
Yes,
So
that's right.
I'm assuming most of you play games. That's probably why you're here. So at least that's why I got into the industry. So you've probably heard of people complaining when the game is at 60 frames per second and then it's just running very smoothly, and then it drops to 30, and then it gets a little bit juddery sometimes. And yeah, that's because there isn't enough frames rendering the world in time, so you can sort of notice when the game's running a bit slower. I think the eyes can spot differences beneath 27 frames per second. I think that's the visual limit,
yeah.
supposedly.
Yeah, so you are right, the game engine usually have multiple loops which kind of go from the beginning to the end. And for example, it needs to detect when the events happen. So like pressing the keys or moving the mouse and things like this. They run really, really fast because you want the game to be as responsive as possible to the human input. But for rendering, for displaying the actual graphical things on the screen, you don't have to run it super fast. You want it to run 60 frames per second or 30, depending on what the screen is capable. If your screen is capable only of refreshing 30 frames per second, there is no point you trying to display something more frequently than that, right? So most displays are capped at 60 or 90,
Yeah.
And that's the target. That's how you run your renderer.
Okay, so following on from frames per second.
Yep.
So let's say we want to move this box when we press the arrow keys. We want to translate it by a certain distance. So the game object is the capsule here, and then it has these components. So this is a component of the game object. So if I get my game object, I can get its transform, which contains its position and rotation. And then from that I get the position, and then there's, in C#, you have these things called properties, and you need to think of them like they are methods for getting access to a variable. So there's like a get and set method to a variable. So here, if I want to basically, I want to set the object. So if I say if the position equals, and this is a vector. So new vector 3. Who's familiar with what a vector is? Yeah. Who's not familiar with what a vector is? Okay. So a little bit of math.
So let's imagine you're above the ground and you're looking down. So you see the floor, and this is the I guess the z-axis, isn't it? So the z-axis. So forward to z, and then this is the x-axis. So let's just ignore up and down, which is the y-axis. So if I want to move one step forward, like in British we call this a foot, because we still have the imperial system. It's got its merit.
Like what?
Yeah,
we can
let's
have
spend
this-
the rest of the lecture.
We can have
this.
this. It's precisely because like I don't have like a meter or measuring tool with me. But you know, what's 1 foot? Simple. Like if you're out in the fields of Africa and you need to measure something.
It's so good that we don't need precision in our discipline here.
We don't need precision. Precision is relative.
Overrated.
Even floating points aren't consistently accurate. Anyway,
Yeah.
so let's just say I want to move forward 1 foot, which is like 0.6 meters. Polygon. There is a vector is basically telling you this is the displacement, this is the translation of me in this 2D space. So if I want to go forwards in, let's say, x, y, and z, I'm not moving at all along the x-axis. I'm not shifting. I'm not going up and down. So y is nothing. But I am going 0.6 meters. So that's my new vector 3. So you also have like vector 2s, which are just x and y, x and z, sorry. So you don't have y. You only have 2 units there. But vector 3s have 3 units.
Does that make sense, everyone? Follow, right?
Yeah.
So it's a movement in space, right? You're basically moving in space, and it could be, if you go up the staircase, you're moving, upwards, and if you're moving forward, like this, Richard just showed this one.
Yep.
So basically, you need to all fill all 3 fields. In this case, he just cares about the Z movement, right? Was it? Z movement.
So
If the
let's
space is 3-dimensional.
If the space.
yeah. So let's say I can move
1 meter.
per second, or let's say I'm quite quick and I can do 1.5 meters per second. So what we want to do is we want to say if we're going forward 0, 0, and then speed. So that's I'm going up. The up arrow should move them forwards. If we're going down, we're going backwards 1.5 meters, and if we're going left, I'm also running quite quickly. So that is along the x-axis there. Who can see a problem with this function there?
Your speed will be decided by how fast your frame rate is.
Yes. So this is running multiple times every second, for instance. So actually what I want to do is I want to find the time between this frame and the last frame. So basically how fast I'm running relative to the last frame. So we can do this by using the time class and getting the difference in time. Delta, you can thank the ancient Athenians for delta. It's like an old Greek symbol. But yeah, it just means in this context a difference. So the difference in time. So if I scale my normal speed per seconds by how many seconds have passed, then that will give me a consistent speed no matter what the frame rate is.
Yep.
So let's.
So the delta time returns the difference between the previous update call and this update call, how much time lapsed.
And that, yeah, thus scales your speed to how fast your game is running.
Yeah.
How noticeable is the difference going to be actually? How noticeable is the difference going to be between just doing speed and speed times delta?
Well, what might happen is, say, you know how if you open up another program or you start watching a movie, then your computer gets a little bit slow suddenly. So then your frame rate would go down suddenly. What would happen then is your character would jump around. So you might not.
It is noticeable.
It is noticeable, but it's only noticeable when the frame rate fluctuates. Otherwise, the frame rate would be pretty consistent, and you might not notice.
Between devices, right? So in
But between devices,
in
yes.
a player context or something like this, maybe an issue. And
Yeah.
there's other ways of dealing with this, but that your PC and your friend's PC would suddenly have a vastly different behavior of the
Yeah.
player character.
In the old days, when the PCs had the turbo button, sometimes to pass the difficult level, you kind of
Speed up. Yes.
yeah. And then you can have a different behavior based on the frame rate.
In a multiplayer game, it wouldn't be very fair because you'd be faster than your
Exactly.
than your friend. So let's. Yes, so it would move much faster than normal. So let's. Oh, I'm using WSD. Oh, this seems alright. Okay.
But can you see the capsule?
Yep. Oh, okay. So, who's seen the problem now? Basically, I've just said it. I haven't. This shouldn't be 0. This should be the last position. So I've been rather foolish here.
Oh yeah, because you reset it to the origin.
So what I want to do is, I want to just say, this is the difference. There's a keyword here that you can use in Unity, which is kind of, and C#, which is kind of a cheat. It's just the var keyword, and that basically means you don't need to tell it what type it is. That's just syntactic sugar. So basically, it's a vector 3. So I want to update the position. So now I'm going to say it is. This position, the previous position, plus the difference that frame. Yeah. So if I move that down to the bottom, and if I save this, I have to define it up here though. Yep. And then it's going to complain because it's unassigned, so I'm just going to say vector 3. I'm just going to say this vector 3 is 0, 0, 0, 0. And then initially, and then I define it based on input. Then Unity will compile the changes to scripts. It will just realize that automatically.
Yep.
Did it move?
Yes.
Yep, there it goes. He's off. Bit slowly.
Yeah, too slow.
Too slow. So let's just change the speed. Ah. and even let's do it a fun way. So let's put this speed into the inspector, so then we can tweak it at runtime. So let's set it to a default value of 0.5. Public. So who knows what a floating point variable is?
Yeah, they should know.
Somebody brave, answer. This man. You put up your hand, didn't you? You know what it is. You just know. It's what I mean. It's like a decimal number. It's not a precise number. It's not a discrete number. It's like you can have half of a jacket or 1.5 of a jacket.
Yeah.
So
what does this serialize tag there, the annotation, do that you just said it?
yeah, serializing. I said it earlier. You need to think of it as in serialize means save.
Yeah.
So like you're saving that data to the Unity scene.
Right.
So therefore Unity scene can see it, and you can change this value at runtime.
And it's visible in the
Yeah.
inspector. So by doing that in the code, now you have access to it from the inspector.
One of the nice things Unity has is these attribute tags. These are the square brackets. So Unity has quite a few of these. One of them is range, for instance, the range attribute. And then you can set it between 0 and let's say a maximum speed of 100. And then Unity has different drawers for the different variables, and it has a special one for the range attribute, and it creates a little slider. So you can either set the value here, or you can slide it between the minimum and maximum values, which is 0 and 100. So it was like on 1, let's just put it up to 30 and see how fast he moves. So this is like, I can remember when I worked as a tools programmer, like you would have the artist and you'd be like, oh yeah, I want to make this swamp, and then I want to have all this gameplay set up, and you'd be like, okay, and it's like, so what's the problem? It's like, well, I can't select the grass and rotate it round. I'm using it with an animation, and it's like, okay, I'll make the tools for you. It's like, can it be a slider? And then you're going back and forth over months. So saving so much time having this done for you.
Yep.
So here, moving.
Because it reacts to the event of you pressing the key down. So press the keys down to move it. It doesn't register the key is already pressed. It only registers the action of pressing the key down. Right?
Yeah. So let's try and find another one.
Yeah, but we have to wrap up.
Yeah.
Do we?
Yeah.
Oh no.
Slowly getting excited.
Understood.
But thank you for the overview. That's very helpful.
Yeah. So we shall continue on Friday, and then on Thursday we'll have the next lecture session, and no session on Tuesday.
So
Yeah.
this Friday or next Friday?
No, nothing tomorrow. Next Friday. Good catch.
Which one?
Oh, we have to check. Yeah, and ask Sayonara.
Okay. So we do a bit of this.
Yeah, but hold on. No, you will not have C-sharp code. Other concepts, like the concept of a mesh, or the concept of texture, or the little terminology.
Tying together basically, right? So what is in space
We will not
don't worry.
put C-sharp into the exam. Maybe we should.
Oh, I should start.
I have the second.
Yeah, sure. I'll just